All right, thank you for joining us today. And in this video, we are going to talk about absolute value, right? So before we start, let's try and assume that we have y to be equal to, let me say, absolute of, let's say, x, right? Now, when you talk about absolute value is like plus or minus. So I can write this one like something like plus or minus x. And this is how it goes. If x is positive, it goes with a positive. If x is negative, it goes with negative. So you see that absolute of -1 is 1. How? Because absolute of this one, we know that the sign here is plus or minus. But since this is minus, it goes with a minus, right? So I'm going to have minus minus 1, and this will be 1, right? And then when y is positive, since it's positive, this one goes with a positive 1, which is also 1. So that's the idea of, you know, absolute value, right? But another thing that we can do is we can actually write it this way. So x absolute is equal to, I pick my piecewise function, then I'm going to have x, negative x, and positive x. So as I said, we have the plus and we have the minus, right? Then this is if, so if x is negative, then all values of x are what? Less than 0. They should be negative. So that's why I said um, negative goes with negative. So if this one is negative, then all values of x for this one should be less than what? 0. So x here is less than 0. Then if x is positive, then we said it should be only positive value. So we can assume that s is greater than or equal to 0. So this is the basic something that you need to, you know, learn. When you are doing statistics too, mostly when you get to higher levels more, you should be able to learn how to do this so that when you are doing integration and then you have the function in this form, you will be able to split the function into this, and then now you can integrate along from 0 to either negative infinity and 0 to positive infinity. So this is very useful. So what is the graph for absolute of x? It's very simple. So as we know from here, now x from the negative side are all values of x less than what? 0. So when I do that, I'm going to have something like this. I'm going to have something like this. So this is when y is equal to x, and this is when y is equal to minus x. Is that right? So this is what I'm going to get. This will be the graph. Very simple, right? So that's what I'm going to get for the graph. So this is the graph. Very nice here. Very nice. So now we need to learn some properties before now we get to the idea of solving more examples. So let's learn some properties, some theorems that we need to know, right? So if we let a b belongs to real, then the following are true. 1, a is less than or equal to absolute of a. Is that true? Yes, this is very true. For example, if a is equal to -2, then what is absolute of a? It's -2, which is 2. So you see that 2 or -2 is less than or equal to this. The reason why we are adding equal to is it can be positive, right? So if a is 2, then what will be absolute of 2? Still 2. So that it will be less than or equal to 2. So that's very simple to prove from there, right? Another thing that we need to learn or also know from here is, before we start, is absolute of a b is the same as, this one is equal to absolute of a, absolute of b. You will be using this a lot in when we start doing some of the functions. Like absolute of this can be written as this one too. Then This absolute of a minus b is, yeah, indeed the same as b minus a, right? So this is another one that we can also learn, you know. Then another one that we are going to also use is when I have absolute of a minus b squared. This is the same as a minus b squared, because actually the absolute, because of the square can make a negative positive, so you can just change the absolute to what? Parenthesis, and then you have it there. Then another one too that you need to learn, which is v, is root of a squared is the same as absolute of a. Yes, so that's one thing that also you need to learn from here. Do you need to learn anything? Let me add like two or three. Then we do some examples before we get to the next video. Then we do more examples to learn how to do the stuff very well. So absolute of a plus b is less than or equal to absolute of a plus absolute of b. So this is a triangle inequality. Then in I we can talk about absolute of a minus b, and we can say that this is greater than or equal to absolute of a minus absolute of b. Good, 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 good. And we can just add this one to it. Absolute of a minus absolute b absolute. This is less than absolute of b minus a. Right. So I think we can just pause here, and then we take more examples. Let's take examples. Then when you are done with the example, the next video, I will introduce intervals. Then when we are done with the intervals, we are going to solve more examples, and then we can represent our solutions on what interval level, right? So let's take some example. Let's take some example so that we can understand it better, right? Let's take some example. So now here, let's assume that we want to solve. So you will learn the tricks, things that you need to know. So we want to solve a question like this. Solve absolute of x minus 2, which is equal to 1. So as I said, with absolute, we have two sides. We have the plus and we have the minus. So I'll show you all the ways, like how you can go through this process. So one way that you can do is, now we know that we can change this one to plus or minus x minus 2 is equal to 1. So what I'm going to do is, I'll consider the positive sign, solve, consider the negative sign, and what? Also solve. So the positive sign will be plus x minus 2 is equal to 1. When I multiply plus, I'll still have something like this. S is equal to 1 plus 2, and s will be equal to 3. That is one side. Then I'll consider the negative side, which will be minus x minus 2 is equal to 1. But here, when I distribute the minus, something happened. This one will be minus x plus 2 is equal to 1. So this one will be minus x, which will be equal to, I move the 2, 1 minus 2, minus s is equal to minus 1. I divide through by minus 1, and I have x to be equal to what? 1. So you see that I've gotten them. So I can say that the true set, the truth set, the truth set, the truth set is s is such that s is equal to 1 and 3. So this is one side, right? This is how I can go through the solution by this. The other side is, now since we have absolute of x minus 2 to be equal to 1, what I can do here is, you remember we using the piecewise function, this, right? Good. This is a piecewise function. So either we use this or we use the piecewise function. So one thing that you need to learn is each function and how you can apply. So maybe we are using this one for when the absolute is 1, just 1, like this. Do you get it? Maybe the other one, it's not going to be like that. So you should be able to practice more to understand how you can go through that. So absolute of x minus 2 is equal to, so my piecewise function, as I said, is the same thing here. We pick the positive, we pick the negative. So what will be the negative side? This one will be the negative, right? And then the positive side. So you see that this one is the one that we had here, and this one here is the one we had here, right? So positive and negative, comma. Then x minus 2, the one in the bracket here. Remember, we said the one in the bracket here, if we are having negative, then all the values here should be negative. So it means that the x minus 2 here in the parentheses should be less than 0. Then this one for this x minus 2 should be greater than or equal to 0. Is that right? Good. We include the 0 when the function is like a linear form like this. It's not a fraction. If it's a fraction, you will see how we are going to exclude this one. Right. So what can I do? I can actually simplify this and have minus 2x. Now I'll plus 2 plus 2, or I'll move the minus 2 to this side. So I'll have x is less than minus 2, x minus 2, x is greater than or equal to minus 2. So this is what I'm going to have, right? So this is very simple. What I'm going to do is I'll pick this side and equate it to 1. I pick this side to and equate it to 1. So you see, like this, which is the positive side, which is equal to 1, and the negative side, which is also equal to 1. So the same thing. So minus x minus 2 is equal to 1. So this implies that when I distribute the minus, minus x plus 1 is equal to, so this one's supposed to be 2. Yes. Is equal to 1. Minus x is equal to 1 minus 2. Minus x is equal to minus 1. I divide 2 by minus 1, and I have x to be equal to 1, as we had it here. So we saw that we had this one to be 1 with the minus side. Now let's look at the positive side. This is the positive side. So x minus 2 is equal to 1. S is equal to 1 plus 2. S is also equal to 3. The same here. Then you write your true set to be this. So as we are learning absolute, you will see the various techniques. So I'll make sure each question that we are going to solve, I'll make sure I get all the strategies and then the skills and then the shortcuts for you to go through them. So this is how we can go through this particular question here, right? So I'll take one question on another question on this, right? Then in the next video, we will talk about open interval, close intervals. Then we start with a lot of examples. We practice from there, and then we can move to maybe either logarithm or rational functions and do stuff. So let's look at this last example in this video. We want to solve x minus 5 less than or equal to x plus 1. Right. So you see that this that we have here, we have two absolutes, right? Good. So if I'm using the idea of what we just learned, the other one, then this one I will be like, okay, this one will be plus or minus x minus 5 less than or equal to plus or minus x plus 1. So how many permutation am I going to do? I'm going to pick positive here, positive here, positive here, minus here, minus here, positive here, minus here, minus here. Some will work, some too will not work. Do you get it? So that's the idea. When you finish, then you combine all of them on the number line, then you solve. Is that right? And the other way that you can do is the same thing. When you use the piecewise function, you pick this one, you do your piecewise function, you pick this one, you do your piecewise function. Then you combine them, this and this, this and that, this and this and that. So let me do the piecewise function. Very quick. X minus 5, absolute will be minus x minus 5, x. So when I solve it, this one will be 5 minus x minus 5 less than 0, then x 5, x minus 5 less than 0. So here when I move the 5 here, when I move the 5 here, I'm going to have x is less than 5, x is greater than or equal to 5, right? Then let's look at absolute of x plus 1 minus x plus 1. So x should be less than minus 1. Then x plus 1, x should be greater than or equal to minus 1. So you remember what I did here? This is like x plus 1 less than 0. Then I move the 1, which will become minus. So when you compare this to this and this to this, you pick the minus here to multiply the minus, right? So it's going to be, the first equation will be like minus x minus 5 is less than or equal to, because remember this is here on the left. So when I pick this one should be on the left. Less than or equal to the one that I'm going to pick, which is on the right, right? So I'm going to have something like minus x plus 1. Do you get it? Then when I finish, I'll pick this guy here and then the positive here. So minus x minus 5, x plus 1. Do you get it? Then when I finish, I'll pick this guy here and this guy here. So x minus 5 less than or equal to minus x plus 1. Then I'll pick the last one, this and that. So x minus 5 less than or equal to x plus 1. Some will work, some is not going to work. So you can see that this is not going to work. Why? Because I have x here, I have x here. When I move x here, this becomes 0. So this is not going to work. Let's look at this one too. I have minus x here when I multiply. I have minus x here when I multiply. When I move it, it's going to cancel, so I cannot find x there. Now let's now look at these two here and see what you are going to get. The first one, when I distribute the minus, I'm going to have minus x plus 5 less than or equal to x plus 1. Make x a subject. So I'll maintain the 5 here, bring the 1 here, and move this x here. So when I bring the 1 here, I'll be minus 1 less than that. Then x plus x. This one will be 4 less than 2x. I divide 2 by 2. 2 will be less than or equal to x. So this implies that x is greater than or equal to 2. Is that right? So this is what we're going to get. Let's look at it. So this is what we had here. Let's look at x minus 5, which is equal to minus x plus 1. Let's see what we are going to get from there too. We are going to have x minus 5 less than or equal to, when I distribute the minus x plus 1, no, minus that. Then I'll move the minus here, minus x here, so 2x less than or equal to. Then I'll move the 5 here, so I'm going to have minus 1 plus 5, 2x is less than or equal to 4. I divide 2 by 2, and x is less than or equal to 2. So now you've gotten two equations. One is saying that x should be less than or equal to 2. One is also saying that x should be greater than or equal to 2. So we need to test, right? So let's come to where we started and let's go and test. We saw that one, x is saying that x is less than or equal to 2 and s is greater than or equal to 2. So which one is which? If value here is less than or equal to 2, so we need to pick any value less than 2 and check if it satisfies the equation. So anything less than 2, we can think of 1. 1 is less than 2. So let's plug in 1. When I put 1 here, I put 1 here. When I put 1 here, 1 minus 5 is minus 4. Absolute of minus 4 is 4, less than or equal to, because I have this one here. When I plug in 1 here, 1 plus 1 is 2. Absolute of 2 is 2. Is 4 less than or equal to 2? No. So it means that this is automatically not going to be true. And then let's check this one. X should be greater than 2, right? So now I can pick 3. Pick 3 here. 3 minus 5 will be minus 2. Absolute of minus 2 will be 2, less than or equal to. When I put 3 here, 3 plus 1 will be 4. Absolute of 4 is 4. Yes, so this is right. So with this one, we are going to say that x is greater than or equal to 2 to be the result for this equation. Right. So with this all stuff, because we have one absolute on the left and one absolute on the right, if I don't want to go through all this, just compare this, compare that, then what I can do is, let me just write it here again. We had x minus 5 less than or equal to absolute of x plus 1. So I can easily square both sides. So absolute of x 5 squared less than or equal to x plus 1 absolute squared. Now let's look at one property that we saw. We saw that if we have absolute and a squared, we can just change the absolute and use this one. So don't forget, we are going to use this one to a lot and this one to a lot, like them. So it means that this can be written as x minus 5 squared, because the the square would actually make the negative positive. So this one is like you having plus or minus squared. This is the same as plus squared, because actually the negative here will, like, it will be plus plus. Let me see something like that, plus plus, because the square will make the negative positive. Good. So this one will be less than or equal to x plus 1 squared. So let's simplify. This is x minus 5. X minus 5 less than or equal to x plus 1. X plus 1. So simplify, multiply this, multiply that. So x squared minus 5x minus 5x plus 25 less than or equal to x squared plus x plus x plus 1. Good. So I have x squared here cancel out. What will be left here? Minus 10x plus 25 less than or equal to x. This one will be 2x plus 1. So I'll move the 1 here. I move the 10 here. So I'm going to have 25 minus 1 less than or equal to 2x plus 10x. This one will be 24 less than or equal to 12x. Let's divide 2 by 12. And this one will be 2 less than or equal to x. And x is, you can see that x is greater than or equal to 2. Good. So you saw that this is what we had here, the one that I circled. X is greater than or equal to 2. Oh no, let me see. Did we do something wrong here? Because x should be greater than or equal to 2. Did we do something wrong? Oh, it's me that I didn't write it well. It's right. It's right. I didn't write it well. So this one, s is less than 2. So when I want to rewrite it, it should be greater than or equal to 2. Good. So x is greater than or equal to 2. S is greater than or equal to 2. So this is how we do it. So we have a lot of, but you can see that this one is very short. So with two absolute, you can just square both sides and then you just go your way. But with one absolute, what you can do is, where is it? This one. With one absolute, instead of even using the piecewise function, you can decide to just change it to plus or minus, then you just distribute it up and then you go. Right. So see you in the next video. Next video, we're going to solve a lot of examples. We are going to talk about open, interval, close, then we combine with 3 absolute, 4 absolute, and then we look at how we can work through that.